Welcome to, start that over, screen shade. Welcome to yet another Pre-Calc 20 lesson. Today we're going to finish up our study of trigonometric ratios of any angle. So the first thing I want you to do is power through this warm-up here to find the missing values in each right triangle below. So just pay attention to the fact that here you can use the 45, 45, 90 properties, and here you can use the 30, 60, 90 properties rather than wasting your time with the Pythagorean theorem. For C and D, you will have to use Pythagorean theorem. So when you unpause the video, I'll have the answers up for you. Actually, the worked solutions will be up for you, and you can take a look at them and check your work. So go ahead and hit pause now. Welcome back. Here are the solutions for all four of those. So hit pause and take a look through those. See how you did. All right, the next part, fill in the primary trig ratio definitions below for right triangles and position angles. So sine theta, or actually, you know what? Go ahead and try to do this on your own. This is a review from what we did in the last lesson, so you can do this on your own. So go ahead and hit pause, fill these in, and when you come back, I'll have the answers ready for you. So hit pause now. Okay, welcome back. Here are the answers. I don't know why this one's not showing up. Maybe I'll write it in. This one is opposite over hypotenuse. So again, this should all be review, so this should not warrant much explanation here. The next question, what is the relationship? Well, you can always take your x and y values and find r, the radius of that line, just by, oh come on. Just by using Pythagorean theorem. Oops. Equals r squared. Okay. So there you go. The point A, located at 8 and minus 15, lies on the terminal arm of an angle theta. Draw in standard position. Determine the exact trig ratios for all sine, cos, and tan. So let's take a look at this angle in standard position. 8 and minus 15. Okay, so 8 is positive, and that's in the x direction. Minus 15 is negative, and that is in the y direction. So we go positive 8. Let's say it puts us right about here. And we go negative 15, which will be almost double that. Okay, so then trace it down, trace this one over, and your angle in standard position looks something like that. Oops. Yeah, let's go ahead and leave that there. Okay. Get rid of all this mess. Try to keep the things that we actually want. Okay. Okay. Way harder than it needed to be. Okay, this is point A. This is at 8 and minus 15. Now we knew it had to be quadrant 4 because x was positive and y was negative. There's only one place that can occur, and that's quadrant 4. So we want to find the exact trig ratios for all of these things. And we have the x and y value. Okay. So most of this we should be able to figure out right away, fairly easily. Sine theta equals y over r. Now here's the problem. Right now we don't have r. So we need to find that somehow. Cos theta equals x over r. And we know that x is 8. And again, as of yet, we don't know r. So I'm going to just leave those blank for now. And tan theta is equal to y over x, which is negative 15, and we do have both of those, so negative 15 over 8. So even if we were just given tan theta value, we would know the values of y and x, and we could easily find r using our relationship, which is Pythagorean theorem. Okay. Negative 15 squared is 225, 8 squared is 64, and 225 and 64 is 289. 289 equals r squared. You go ahead and take the square root of 289, should end up with r equals 17, and you just go ahead and fill those in, and you're done. Okay, so on to the next question. It says determine the exact value of the 3 primary trig ratios of the angle 135. Now, because it says this is a key word, exact value. We cannot use our calculators here because our calculators will only give us a decimal number that we have to round, and that is not exact. We want to know exact values. So, my first piece of advice to you: draw the angle in standard position. So, start by making a big coordinate axis and let's figure out where this angle is. The angle 135 degrees. Now, this is 90, this is 180. 135 is somewhere in quadrant 2. Okay? Somewhere in here. So 135, in order for this whole thing to be 135, this little area right in here must be 135 minus 90 degrees. So 45 degrees is our reference angle right here. Now we can start to figure out the exact value of each of these things. The sine of 135 will be positive because the sine gives you the y value, or the vertical displacement, and everything above the x-axis is y is positive, everything below the x-axis is y is negative. Everything to the left of the y-axis is negative x, everything to the right of the y-axis is positive x. So this will be a positive y and a negative x. So therefore sine of 135 is the same as sine of 45, and it will still be positive. Now we know that a 45-degree triangle is going to mean this is 45, this is 45. So things we can assume, make some simplifications, call this 1, then we just call this root 2. So 45 is, sine of 45 is opposite over hypotenuse, which is 1 over root 2. Cos 45 is adjacent over hypotenuse, which would also be 1 over root 2, but we know that since the x value is going to be negative, we have to apply negative to this 1, because it goes left, and this is going to be negative 1 over root 2. Finally, the tangent of 45 degrees is going to be the ratio of your adjacent side and your opposite side. Sorry, opposite over adjacent, but in this case it doesn't matter. It's both 1. And one of them's negative, so it would be negative 1 over 1, which of course is just negative 1. So, trigonometric ratios for quadrantal angles. This information is found on page 93. in your textbook. So you can take a minute and fill these in, and then come back and check out the answers. So try to do this entire chart before you unpause the video and look for the solutions. Okay, so go ahead and hit pause now. Okay, welcome back. Okay, quadrantal angle is any angle drawn in standard position whose terminal arm lies on one of the axes, and it could be any one of the axes. Okay, so draw the quadrantal angles from 0 degrees to 360 degrees on the Cartesian plane below, and then we'll talk about finding the trig ratios. So quadrantal angles, we'll have one here, and this of course is 90 degrees. Let's see, 0 degrees, so since it says less than or equal to, then we include 0 degrees, so we have to do 0 as well. So 0 degrees right here. This one is 180 degrees. This one is 270 degrees. Now, do we include 360? No, we don't. So it says less than 360, so we don't include it. Okay, so summarize your findings in the chart given. All right, 0 degrees. Sine theta of 0 degrees. Now, sine theta is y over r. So, what is the y component of this angle 0 degrees? So, how vertical does it go? Well, it doesn't go vertical at all. So, it has no y component, which means it is 0 divided by something, which of course is just 0. So sine of 0 is 0. Now let's look at sine of 90 degrees. We can draw our angle in here. This is the r. Now, what is vertical and what component of it is horizontal? It really doesn't matter what the value or what the magnitude or the length of this line is, because this is our r value, and it turns out that the entire r is strictly y component. So in this case, r, the radius, would be exactly equal to y, which is the vertical component. And since they're equal, sine theta equals y over r, and if y is equal to r, then it's just something divided by itself, and that value will always be 1. Now let's look at 180 degrees. 180 degrees, what is the vertical component of 180? And again, this is just on the horizontal axis, so it has no vertical component. Since there's no vertical, y is 0, and sine of 180 is also 0. You can verify all of these on your calculator as well. Now, if we look at this one, 270 degrees, we can draw our radius in. Now, radius is a distance, so it's always positive. But what component of this radius is in the y direction? Well, we know this is in the negative y direction, and the entire radius, r, is strictly 100% in the negative y direction. So in this case, r equals negative y. So we have negative y divided by r, so we have a negative something divided by itself. That means this will give us a value of negative 1. Okay, we can move on to the cos values. So cos is x over r. So first let's look at 0. What is the x component of this radius, r? And it turns out in this case, r is equal to the x component, so it's something divided by itself. Your value is 1. At 90 degrees, this is vertical. There is no left to right x component. So x is 0. So it's 0 divided by something. And that will give us 0. At 180 degrees, now this goes in the negative x direction. Now again, the radius is always a positive number because it represents a distance. So r equals negative x. And that means negative something divided by itself will give you a value of negative 1. At 270 degrees, again, this is on the vertical axis. There's no left or right component, meaning x is 0, and 0 divided by the radius would just give us 0. Tan theta, we don't even need to look at our Cartesian plane anymore. We can just look at these values. Tan theta is y divided by x. So it's this one divided by this one divided by this one. So 0 divided by 1. Tan of 0 is 0. Tan of 90, 1 divided by 0. Now again, recall that tangent basically represents the slope of the line. Now, if at 90 degrees we were to look at this slope, okay, this slope is vertical. It goes straight up and down. Essentially, that means it has an infinite slope. Now, 1 divided by 0 is essentially infinity, but we're not allowed to divide by 0. So we call this undefined. Cannot define that slope because it's infinite. At 180, again, tangent is the slope. So what's the slope of this line? Well, it's completely flat. It's horizontal, so it has no slope. And we can verify that again with y divided by x. 0 divided by negative 1 is 0. And that's what no slope means. Then for 270 degrees, negative 1 divided by 0. And again, you cannot divide by 0, so this one will also be undefined. And you can verify that just by looking at it and realizing, yeah, this is an infinite slope in the negative direction. So here's an example that we'll quickly go through. Suppose theta is an angle in standard position with terminal arm in quadrant 3. This is very important information that you cannot overlook. And cos theta equals negative 3/4. Okay. What are the exact values of sine theta and tan theta? Now, this gives us a lot of information. Cos theta equals negative 3/4. And we know that cos theta is represented by x over r. R is always positive, so r is positive 4. Which means x is negative 3. And we could have predicted that anyway because we were told that this is in quadrant 3, and we know that in quadrant 3 over here our x value is negative. Okay? We also know that in quadrant 3 our y value is negative, and that's going to be important information as well. So how do we find the sine? Well, we need our y value in order to find the sine. We can find that using our Pythagorean theorem. Negative 3 squared equals r squared, which is 4 squared, minus y squared. So 9 equals, and I don't know why I did it this way because now I'm going to have to make adjustments. 9 equals 16 minus y squared. So let's swap the y squared and the 9. Y squared equals 16 minus 9. Y squared equals 7. Y equals root 7. And this could be a plus or a minus root 7. We wouldn't know for sure except that we're told that this is in quadrant 3. And in quadrant 3, the y value is always negative. So we discard this and we accept y equals a negative root 7. So then sine theta equals y over r, and that will be negative root 7 over r, which is 4. So negative root 7 over 4. Tan theta equals y over x. So tan theta is going to be y, which is negative root 7, over x, which was negative root 3, and of course the negatives cancel and we get root 7 over 3. And if you think about an angle in quadrant 3, it would look like this, and since it goes up from left to right, it would have a positive slope, and since tangent is the slope of this line, we should end up with a positive value, which we did, so that's great. Example 3, your turn. Go ahead and give this a try. When you unpause it, you can check out the solution on the next page, so hit pause now. Okay, welcome back. Here's the solution for example 3. Hit pause, take a look, compare it to the one that you just did. Example 5, I guess we're skipping example 4. Solve for an angle given its exact sine, cosine, or tangent value. This one will be really quick. Solve for theta. Sine theta is given to us as 0.5. Now, sine theta is given to us as 1/2. Write this as a fraction because we know that sine theta is y over r, and therefore right away we can deduce that y equals 1, the numerator, and r equals 2, the denominator. Alright, and then we can solve for x right away using Pythagorean theorem. So 2 squared minus 1 squared equals x squared. Therefore 4 minus 1 equals x squared. X equals root 3. So there you go, root 3. Now you might recognize that this is a special type of triangle here. Whenever the hypotenuse, r, is double the shortest side, that is a 30, 60, 90 triangle. The angle theta could be between 0 and 360 degrees. Let's figure out exactly what we have. Now, we know from our earlier discussion that we have a 30, 60, 90 triangle. So there are a couple possibilities here. We could have our triangle. So our reference angle is going to be 30 degrees because the short side will be the y value. So we have an angle here, and this would be 30 degrees. Or, since y was given to us and we knew that the sine of the ratio was positive, we could have our angle right here with the reference angle of 30 degrees, meaning this whole big angle is 90 plus this, which is 60, and 90 plus 60 is 150 degrees, and that's how we get our two answers down here. Okay. So here's another, never mind. Here's another your turn. Go ahead and give it a try. When you come back, as always, the answer will be on the next page, so hit pause now. Here's the answer. Hit pause, look through it, see how you did. Finally, one last example here. Solve for the angle given its approximate sine, cosine, or tangent value. So we are given an approximate cosine value here, and we're told that the cosine value is negative. Now, when the cos is negative, that gives us two possibilities: an angle in quadrant 2 or an angle in quadrant 3. If you try to cheat and use your calculator, this will only give you one of the two possible angles, and it will give you this one right here. So if you wanted to go ahead and cheat, you will find out that this is 135, and that's all you will be told, and then you will only get one of the two possible answers, and you lose half the marks on any question that you do in an assignment, we need to identify all the possibilities that will give us this. So what we do is we want to find a reference angle. So find the cosine of the same value, or sorry, find the value of the angle when the cosine of that angle is positive. You find out that we get a reference angle of roughly, two squiggly lines here, roughly 45 degrees. So that means our reference angle is 45 degrees here, the reference angle is 45 degrees here. So we already knew that this is 90 plus 45, which is 135 degrees. That's one of our answers. And we have to find this one here as well. So 180 will get us from this axis to this axis in this big loop. And then we have to add another 45 degrees. So 180 plus 45 will give you an angle of 225 degrees. These are your two possibilities. Go ahead into your calculator, type in cos 135 and type in cos 225, and you will find that for both cases you will get the same answer, and it will be this answer, and they'll both be negative. So here's your last your turn. Go ahead and give it a try. Hit pause now. Here is the answer for your turn, so take a look through. Just wanted to remind you that everything above the x-axis is positive for y, and everything below it is negative, so that's how we came to this conclusion. Okay, that's it. See you in class.